Centrifugation is based on centrifugal force. As when something rotates in a circular pattern, two forces are acting on that thing. Now, this is a circular path that the object in my circle is under. Let me try and drive that down. For something moving in a circle like this, two forces are acting on that thing. There's a force that is pulling the thing towards the center, and that force is centripetal force. And there's also a force that is pulling it away from the center of the circle. That force is centrifugal force. So centrifuge or centrifugation is based on centrifugal force. We use that method to separate solid particles from liquid. And a centrifuge is a machine which can spin test tubes containing suspension at a very high speed. So if I have a test tube, maybe containing a suspension of chalk or blood, I'm not using blood here because centrifugation is used extensively in the medical lab to separate blood components, by separating plasma from or serum from blood cells and platelets. So if I have blood in this test tube and I want to remove the plasma, which is the liquid, I need a centrifuge machine. A centrifuge machine is designed in a way that you have slots for test tube, slots for test tube. These are slots for test tube. So we can insert a test tube here, insert another one, insert another one, insert another one. Then all of these slots are attached to a spinning wheel that can spin at a very high speed. The spinning wheel here can spin at a very high speed. So as it spins, the test tube containing the suspension, all the solid particles in that suspension will settle to the bottom of the test tube, while the supernatant layer, the clear layer, will be the liquid component of the suspension. So that kind of a separation method is made use of in the hospital and medical lab to separate blood cells from blood plasma. I have a simulation on that. Let's watch it. Okay, it's just a schematic representation of what happened in real life. See the real test tube here by the left hand side. And see it here, there are test tube inside the centrifuge here. Is the real life centrifuge here. What I have here on the right hand side is just a schematic representation of what is going to happen inside the test tube, the centrifuge machine. So this test tube, we insert this one here, insert this one here, insert this one here. So let's look at it. You see I'm depicting that. Inserting the test tube, then we cover it. You can see now we're spinning it at a very high speed. We're spinning right now at a very high speed. Spinning, 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 spinning. Then the spinning is done. You can see now the blood has been separated into components. The dark component is a blood cells, while the supernatant layer that is what color is this? Light yellow represent the blood plasma, which is a liquid component of blood. So now what separates this is the centrifugal force. The centrifugal force push all the solid components to the bottom of the test tube, while the liquid layer remain at the top. This liquid layer at the top, we call it the supernatant layer. Okay, now this supernatant layer now can be decanted, which is a method of separation we talked about earlier. Just decant it gently to make use of whichever analysis you want to do. So we are removing the test tube now. Okay, that is centrifugation.